Hi everyone. What we're going to work on now is how to make a sheet of graphene in Spartan. So there's graphite, right, that's used in pencils and water oil, and it's sheets of pure carbon, and graphene is a single sheet, right? And so it's kind of a different material in a way because it has some really unusual properties in terms of its ability to conduct heat and electricity, and the fact that it can be a single atom thick but still be a meter long hypothetically. And it's getting used more and more in industry. So let's give you guys a good visualization on how to do this. So first we do our new build. So this is going to be all 6-membered rings, okay? And let me stretch out my Spartan a little bit here. All right, so if you come down here to rings, right, in mine it's brownish rings, and I'm going to select benzene, okay? And then benzene, I'm going to click here, because really what you have is basically a bunch of lines of benzene. All right, and so I have benzene here. Now I'm going to make this 6 benzene molecules long. So 1, 2, 3, 4, 5, and 6. Okay, so that's gonna be my building block. I'm gonna make it a little bit smaller like this. Remember, you're working with a decent number of atoms now, so the program might move a little slow. Don't rush it. I'm going to put my fingers on both buttons on the mouse. I'm going to make the square. All right, make sure you get the whole thing inside it. And it should turn fuzzy. And then edit, copy, and edit, paste. And then I'm doing a control right button thing. And I want to make 6-membered rings, right? So let me make this a little bit bigger. So let's say I did it like this, and I look right here. This is a 4-membered ring and an 8-membered ring. I don't want that. What I want is this, right? You can see where I'm going to have 1, 2, 3, 4, 5, 6, and I'm going to have that on all of them, okay? So now I'm going to zip this up. I'm going to make the bonds. Okay, I'm going to just go right down 1, 2, and again, this, you're going to give it a second, let it make it the bonds. Don't rush it. Okay, and then 1, 2. You can make this a lot bigger if you wanted to. It's just that it would take you more time with more bonds. Okay, and you see I'm making 6-membered rings. 1, 2. Then I'm going to do 1, 2. Okay, 1, 2. Right, and you can see how I have these aligned. It's so that you're going to make basically kind of like a square. It doesn't have to be a perfect square, but you don't want it to have rings flip-flopping by themselves somewhere. 1, 2. Okay. 1, 2. One, 2. One, 2. And then 1, 2, right? Okay, now I'm going to come down here to the energy button and minimize that, pull together. All right. right? And so I'm going to do one more copy on this. I'm going to make this a little bit smaller. I'm going to press there to get all those things to go away. I'm going to make like this, make my box. And remember, you want to get the whole thing in that. And then edit, copy, edit, paste. Right, and I'm using that control right click button, and again I'm aligning these to make 6. I don't want to make 4 and 8. I want to make 6-membered rings. Okay, and I'm going to make it a little bit bigger so it's a little bit easier for me to see. I click down there, just give it a second. Okay, so now I'm going to make some bonds. And same thing. 1, 2. You remember now there's even more atoms, so it's going to go a little slower. So don't start clicking them all at once. You might crash your program. 1, 2. Okay, and let's do it. We can come down here. Let's just do one here. 2. So this is a single sheet right here. The way graphite dust gets used in motor oil, it's kind of like a pencil. When you have a pencil and you write individual sheets of graphite come off, or graphene come off on your paper. That's what you see, is the sheets of graphene, the individual sheets. That's why a pencil works, right? It's not an ink, it's actually a solid carbon that comes off. And that's what happens in motor oil too, is you have little flakes of graphite in there, but as it rubs up and down in your piston, that it actually rubs off on a surface, and this is actually a pretty smooth material. Okay, so 1, 2. Let that go. You'll notice all the carbons have 3 bonds. That means that they're sp2 hybridized. You know, 1 double and 2 single. Okay, so sp2 hybridized is what's in graphene or graphite. Now, if we were to take this and copy and paste it a bunch of times and stack them on top of each other, right, that would be graphite. Okay. Graphite's naturally occurring. You can actually find it in the Earth's crust. All right. You can see when that little blue arrow happens, that's when it starts doing the calculations to connect the 2 lines. It's not, remember, this is not just a picture, right? There's a whole bunch of quantum mechanical calculations behind it. That lets you calculate different parameters. Okay, so one of the things that you're going to do with this will be our final sheet after we make all our bonds and minimize it. If you want to keep making it bigger, you can, but as you can see, it'll just take you some time, and you're going to get the same results anyway in terms of a sheet of graphene. Nobel Prize, if you did the pre-lab already, you know, was won for graphene. Maybe it was roughly 10 years ago. But how they did it was they would take one of their easiest ways of getting individual sheets of graphite was to take Scotch tape and put it on graphite that went into a pencil, and then just lift it off, and on the Scotch tape there would be individual sheets of graphene that were pulled from the surface. Okay, so this is our last one here. Right, so there are some simple ways of making it, but if you're making electronics that have to be incredibly reliable and reproducible, right, you're not going to make it in air, and you're not going to make it with Scotch tape. But that's just a simple way to show that it could be made. Okay, so I'm going to hit the minimize button, pull it all together. Let that run for a second. Okay, so there's my graphene sheet. All right, so one of the things you have to do is measure distance. And so you remember distance, you go up to geometry, and then measure distance. And you're going to go from one end straight down to another. right? You click on each one, and in your lower right hand corner, right, your distance should pop up. Now remember that sometimes this folds over itself, so you may have to make it, so this, what I just did was 23.4 angstroms, roughly. Okay, and you're going to do length times width, right? So you just pick an atom, and then straight there, length times width, and then you're going to do diagonal from both corners to the opposite corner, okay? And then the third thing you're going to do is come up to geometry and measure angle, and you're going to pick 6 angles to measure, right? And so you're going to do them in a row. So like you might do, for example, right here, 1, 2, 3, right? And the angle again will appear in this lower right hand corner. And again, don't rush it. Don't just start hitting buttons because you're in a rush. It will pop up. Okay, so it doesn't come. Let it come. All right, and the angle is 120.34. Okay, and so pick different parts. So pick the outside. You'll have 3 on the outside. Pick, and then pick 3 on the inside, and see if you get the same angle for them. Okay, so so that's where you're going to get your angle at the lower right hand corner down there. All right, so that's your graphene, and you're gonna print this out. You might want to just copy it to a page, because you can just do copied as an image, right? Edit, copy, and then you do something like, say, let's just say you open your PowerPoint, and get a new slide, all right, and just paste it right in there as a picture. Okay, remember you want to have a white background for this, because when you go to print it, all right, you don't want to have purple and then it comes out as some kind of grayish thing. But that's what it would look like right there, right? When you guys, what do you call it? I'm actually going to print it out. You can do it in PowerPoint or Word, whatever you want, but just put it on a piece of paper like that. All right, so that's your graphene. And the other thing that you're going to end up doing is coming up here to display output. Right, I'm sorry, display property. All right, and you're going to get your empirical formula. And the other thing that you're going to get is what its molecular weight, which is there. Right, so here, and then you go into quasar and get your area. Right, you notice that it has no polar surface area. That means it's non-polar. Okay, and you're going to get your area and your volume. Alrighty, and so I'll close this. And so that is the end of the video on how to make. So you notice with this that it's all 6-membered rings. If you remember when you did C60 buckyballs, that it had 5 and 6-membered rings. Okay, so there is a difference there in terms of their structure, in addition to the ball being circular and this being flat. All right, thank you very much.